Arithmetic sequence word problems. Problem number 1. What is the 24th term of the arithmetic sequence positive 4, 10, 16, 22, and 28? To find the 24th term of this arithmetic sequence, first we need to find out what if there are consecutive terms. Okay, so looking at the problem, there are many consecutive terms. We have 4 and 10, 10 and 16, 22 and 28, and so on. So this is an easier problem to solve because there are consecutive terms and we can find the common difference, or D. Okay. We are going to use the formula a sub n is equal to a sub 1 plus n minus 1 multiplied by d. Okay, so d here is the common difference. Again, d, this is the common difference. So d is the common difference. And to find for d, we are going to subtract the consecutive terms. So for example, we will have here 4 and 10. To find for d, we will subtract the previous term from the present term. Okay, so this will be 10 minus 4. So our d here is equal to 6. So d is constant. So no matter what consecutive term you are going to subtract, the answer is still the same. Let's take for example 22 and 28. So our d here will be equal to 28 minus 22. So our d is still positive 6. So since we have the value now for d, we can now find for the 24th term. So to find for the 24th term, our equation will be a sub 24. This means that this is the 24th term. This is equal to a sub 1. So a sub 1 is the value of our first term. So our a sub 1 here is positive 4 plus n minus 1. Our n here is equal to the number of term, and then multiply this by d, which is the common difference. So our a24 now, this will now be equal to a sub 1. Again, our a sub 1 is positive 4 plus our n, which is equal to 24, minus 1 multiplied by d. Our d is positive 6. So a sub 24, or our 24th term here, will be equal to 4 plus 24 minus 1, that is 23, multiplied by positive 6. So a sub 24 here will be equal to 4 plus 23 multiplied by 6, that is positive 138. So our a sub 24, or our 24th term, will be 142. So 142 is our 24th term for the arithmetic sequence 4, 10, 16, 22, and 28. And this is our final answer. Arithmetic sequence word problems. Our problem: what is the arithmetic sequence of 6 terms if 5 is the first term and the last term is 50? So we are going to find 6 terms, and our first term is 5. So 6 terms, 5 is the first term. So let's write this down. Our first term is 5, and there will be 6 terms of 1, 2, 3, 4, 5, and our 6th term, or the last term, is 50. Now looking at this given problem, we can see that there are no consecutive terms. So since there are no consecutive terms, our D here is unknown. Okay, now to find for D, we are going to use the equation of the arithmetic sequence A sub n is equal to A sub 1 plus n minus 1 multiplied by D. Okay, we have here the first term, which is 5, so we can use it here. And then we have here the sixth term. Okay, so for the sixth term, we can have the value for n. Now, for this A sub n, we are going to use the sixth term. We cannot use the first term because 1 minus 1 will be equal to 0. Okay, so we need to use the sixth term. Okay, so let us use the sixth term to find for the value of D. So this will be A sub 6 is equal to the value of A sub 1, which is positive 5, plus our n. Our n here is the sixth term, so this will be 6 minus 1, and our D is the unknown. Okay, so A sub 6 here, we have the value for A sub 6, and that is positive 50. So let's put 50 here, equals to 5 plus 6 minus 1 is 5. 5 multiplied by D, that is 5D. So to find for D, we need to transpose positive 5 to the other side. So transposing this will be 50. If we transpose positive, this will change sign. It will become negative 5 equals to 5D. So we can rearrange this. We can put 5D here on the left. Okay, and 50 minus 5, this will become positive 45. To find for D, we need to cancel out 5 from 5D, so divide both sides of the equation by 5. 5 divided by 5, we can cancel this out. So 5 divided by 5, that is equal to 1. And 1 multiplied by D, that is equal to D. 45 divided by 5, this is positive 9. Our D now is positive 9. Okay, so we are going to find for the second, the third, and the fourth. Again, we need to find for the second term, the third, the fourth, and the fifth. Okay, so let us first find for the second term. Our A sub 2 here will be equal to A sub 1 plus n minus 1 multiplied by D. So our A sub 1 is positive 5 plus our n here is positive 2 minus 1 multiplied by D, which is positive 9. So our A sub 2 would be equal to 5 plus 2 minus 1 is 1. 1 multiplied by positive 9 is positive 9. So our A sub 2 is positive 14. Okay, let us now find for the third term, or A sub 3. Okay, for our A sub 3, our equation will be equal to A sub 3 is equal to A sub 1 plus n minus 1 multiplied by D. Again, our A sub 1 here is the first term, and that is positive 5. So our A sub 1 is positive 5. Plus our n here, this is the third term, so this will be 3 minus 1 multiplied by D. Our D is positive 9. So our D here is positive 9. Our A sub 3 now will be equal to 5 plus, okay, 3 minus 1 is positive 2. Positive 2 multiplied by positive 9, positive 18. And 5 plus positive 18, that is positive 23. Our a sub 3 is positive 23. We are now going to find for the fourth term. Okay. The formula for the fourth term, or a sub 4, this is equal to a sub 1 plus n minus 1 multiplied by d. Our a sub 1 again is positive 5 plus our n here. This is the fourth term, so this will be 4 minus 1 multiplied by d. Our d is positive 9. Okay, so a sub 4 here will be equal to 5 plus 4 minus 1 is positive 3. Positive 3 multiplied by positive 9, that is positive 27. And 5 plus positive 27 is positive 32. And the last here we are going to find for the fifth term, or the a sub 5. This is equal to a sub 1 plus n minus 1 multiplied by d. Okay, so our a sub 1 is positive 5 plus n. Our n here, since this is the fifth term, this will be 5 minus 1, and our d is equal to positive 9. So a sub 5 here will be equal to 5 plus 5 minus 1, that is positive 4 multiplied by positive 9. So our a sub 5 now, this will be equal to 5 plus 4 times 9, that is positive 36. So this will be equal to positive 41. So therefore, our a sub 5 is positive 41, a sub 4 positive 32, a sub 3 is equal to positive 23, and our a sub 2 now is equal to positive 14. And these are now our final answers. Arithmetic sequence word problems. Our given problem: what is a sub 1 if a sub 6 is equal to positive 72 and a sub 10 is equal to 120? So again, a sub 1 is the unknown. Our given is a sub 6 equals to 72, and a sub 10, this is equal to positive 120. So the formula for finding the missing terms of an arithmetic sequence is a sub n equals to a sub 1 plus n minus 1 multiplied by d. So d here, this is the common difference. So again, our d here, this is the common difference. Now, to find for d, we need to have two consecutive terms so that we can subtract them. But since on our given we do not have two consecutive terms, what we are going to do is we will use the equation for a sub 6 and a sub 10. Okay, now for our a sub 6, the equation is a sub 1 plus n minus 1 multiplied by d. Our a sub 6 is positive 72. So this will be 72 is equal to our a sub 1, this is an unknown, plus our n here, since this is the sixth term, this will be 6 minus 1 multiplied by d. 72 will be equal to a sub 1, and 6 minus 1 is positive 5. Positive 5 multiplied by d, this will be plus 5d. We are going to call this as our equation 1. For our a sub 10, this will be equal to a sub 1 plus our n here is 10 minus 1 multiplied by d. So our a sub 10, this is equal to a sub 1. So plus 10 minus 1 is positive 9 multiplied by d. This will be positive 9d. This is our equation 2. Now, looking at the two equations, we can see that if we subtract equation 1 from equation 2, okay, so first we have to change this a sub 10 to the value. So the value of a sub 10 here is positive 120. So we need to subtract a sub 1 from a sub 2 so that we can cancel out a sub 1 and we can find the value of the common difference, or D. So subtract equation 2, or rather subtract equation 1 from equation 2. Subtract equation 1 from equation 2. So our equation 2 is 120 equals to a sub 1 plus 9D minus equation 1, which is 72, equals to a sub 1 plus 5D. So subtracting, we will have positive. Okay, so we have 120 minus 72. This will give us positive 48. So we have here positive 48 equals to a sub 1 minus a sub 1 is 0 plus 9D minus 5D, that is 4D. So we have here 48, positive 48 equals to 4D. Positive 48 equals to 4D. So we can rearrange this. We can make this 4D equals to 48. It will not change the value of the equation. So to find 4D, we need to cancel out 4. To cancel out 4, just divide 4 to both sides of the equation. Now, 4 divided by 4, this is equal to 1. We can cancel this out. So 1 multiplied by D is positive D. And 48 divided by 4, this will give us positive 12. Okay, so we have here positive 12. Our D is positive 12. Now, to find for a sub 1, we can use either the formula for a sub 6 and a sub 10. Okay, let us use the formula for a sub 6. Okay, so we are going to use this formula to find for a sub 1. So the formula here is positive 72 is equal to a sub 1 plus n minus 1 multiplied by D. So we have here 72 is equal to a sub 1 plus our n is 72 minus 1. Okay, or rather it's not 72, but this is, since this is the sixth term, okay, let's check if this is, yeah, okay, so this will be 6 minus 1 and multiplied by D, which is positive 12. So 72 is equal to a sub 1, 6 minus 1 is positive 5, so this will be plus 5 multiplied by 12. Okay, so we have here, so 72 is equal to a sub 1 plus 5 times 12 is 60. Okay, we can rearrange this. A sub 1 plus 60 equals to 72. So to find for a sub 1, we have to transpose positive 60 to the other side. So transpose this to the other side. What will be left on the left side will now only be a sub 1, and we will have here positive 72. If we transpose positive 60 to the other side, it will change sign. So from positive, this will become negative. So our a sub 1 will be equal to 72 minus 60. This is equal to positive 12. So therefore, our a sub 1, or our first term, is positive 12. And this is our final answer. Arithmetic sequence word problems. Our problem: if there is a common difference of positive 8 and the first term is positive 7 and positive 71 as the last term, how many terms are there? So our given here, our first term is positive 7, and we have several terms here that are unknown. And our last term is positive 71. So we need to find the missing terms. But it is also stated on the given that we have a common difference, and our D here is positive 8. Okay, so our D is given. We can find the missing terms by using this formula. A sub n is equal to a sub 1 plus n minus 1 multiplied by D. Now, we already have our first term, or a sub 1. Let us now find for a sub 2. A sub 2 will be equal to the value of a sub 1, which is 7, plus, okay, that's plus. So 7 plus, okay, our n here, this is positive 2. 2 minus 1 multiplied by D, which is positive 8. Our a sub 2 here, this is equal to 7 plus 2 minus 1 is 1 multiplied by 8. So this will be 7 plus 8, that is 15. Okay, so our a sub 2 is positive 15. Let us now find for a sub 3. A sub 3, this will be equal to, again, our a sub 1 is positive 7, plus our n here, this is the third term, so 3 minus 1 multiplied by 8. Our a sub 3 here would be equal to 7 plus 3 minus 1 is 2 multiplied by 8. So this will be equal to 7 plus 16. And this will be positive 23. So our third term is positive 23. Let us now find for a sub 4. A sub 4 here, this will be equal to, again, positive 7 for a sub 1 plus our n here will be 4 minus 1 multiplied by positive 8. So a sub 4 here would be equal to 7 plus 4 minus 1 is 3 multiplied by 8. So this will be 7 plus 3 times 8 is 24. So this will be positive 31. Okay, our a sub 4 now is positive 31. So let us now find for a sub 5. Okay, so let's erase this first. We are now going to find for a sub 5. A sub 5 here will be equal to, again, our a sub 1 is 7 plus our n here is 5 minus 1 multiplied by 8. So our a sub 5, this will be equal to 7 plus 5 minus 1 is 4. 4 times 8 is 32. So this will be 7 plus 32. And this is equal to positive 39. Now for our a sub 6. Our a sub 6, again, a sub 1 is 7 plus our n here is 6 minus 1 multiplied by 8. So our a sub 6, this is equal to 7 plus 6 minus 1 is 5 times 8. So this will be equal to 7 plus 5 times 8 is 40. So this will be 47. Okay, so let's write it here again. We will have here the 5th term, the 6th term, the 7th term, and maybe the 8th term. Okay, so our a sub 4, or rather our a sub 5. Our a sub 5 is positive 39. Our a sub 6 is positive 47. So let us now find for a sub 7. Okay, our a sub 7. Oops. a sub 7, this is equal to our a sub 1 is 7, so this will be 7 plus the n here is 7 minus 1 multiplied by d, which is 8. Our a sub 7 here would be equal to 7 plus 7 minus 1 is 6 multiplied by 8. This will be equal to 7 plus 48. So this will be positive 55. Okay, so let's put it here. A sub 7 is equal to positive 55. This is positive 55. So we are now going to find for the next term. Okay, I think we will have here the next. So we are now going to find for a sub 8. A sub 8. Again, our a sub 1 is 7. Plus our n here will be 8 minus 1 multiplied by 8. So a sub 8, this will be equal to 7 plus 8 minus 1 is 7 multiplied by 8. So we have here 7 plus 7 times 8 is 56, and this is 63. So our 8th term here is 63. Okay, 63. Let us now find for the 9th term. The 9th term, our a sub 9. So a sub 9, again, this will be equal to 7 plus our n is positive 9. So this will be 9 minus 1 multiplied by 8. A sub 9 here would be equal to 7 plus 9 minus 1 is 8. So this will be 8 multiplied by 8. Okay, so this will be 8 times 8. And we have here 7 plus 64. So this will be equal to 71. So we will stop here. So our final term is positive 71. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So our final answer here is that we have 9 terms. So we have 9 terms. Okay, and this is our final answer. Our next problem: what is the common difference with a5 equals to 40 and a sub 10 equals to 75? So our given a sub 5, this is equal to 40, and a sub 10, this is equal to 75. Our unknown here, we are going to find for the common difference, or d. So our d is the unknown. The formula for finding the term of an arithmetic sequence is a sub n equals to a sub 1 plus n minus 1 multiplied by d. So a sub 1 is also an unknown here. We do not also have the value for a sub 1. But we have a sub 5 and a sub 10. We are going to use the equations of a sub 5 and a sub 10 to find for the value of d. Okay. So the equation here for a sub 5, this will be a sub 5 is equal to a sub 1 plus n minus 1 multiplied by d. We have a value for a sub 5. Our a sub 5 is positive 40. This is equal to a sub 1 plus our n here is, since this is the 5th term, so our n is 5 minus 1 multiplied by d. This will be equal to 40 equals to a sub 1 plus 5 minus 1 is 4. 4 times d, that will be 4d. Okay. Let us call this as our equation 1. And then we have here a sub 10. So the equation for a sub 10, This will be equal to a sub 1 plus n minus 1 multiplied by d. So the value for a sub 10 is 75. So we have here 75 is equal to a sub 1 plus, since this is the 10th term, our n here will be 10 minus 1 multiplied by d. So we have here 75 is equal to a sub 1 plus 10 minus 1 is 9. 9 multiplied by d is 9d. This is our equation 2. Now, looking at equations 1 and equation 2, we can subtract the two equations so that we can cancel out a sub 1, and what will remain will be the variable d, and we can find the value for the variable d. Now, we are going to subtract equation 1 from equation 2. So we will do this because 75 is bigger than 40 and 9d is bigger than 4d. So again, our equation 2 here is 75. This is equal to a sub 1 plus 9d. Subtract this by equation 1, which is 40 equals to a sub 1 plus 4d. So subtracting, we have 75 minus 40, this will be 35, equals to a sub 1 minus a sub 1 is 0, and positive 9d minus positive 4d, this is plus 5d. So we will have here, we can rewrite this, 5d equals to 35. To find 4d, we need to divide both sides of the equation by 5. So 5 divided by 5, we can cancel this out. This is equal to 1. So d here, our d now will be equal to 35 divided by 5. This is positive 7. So our final answer is d is equal to positive 7.